So, as already stated, my name is Adrian. I'm a senior security researcher with Ixia's Application and Threat Intelligence team, and this presentation is entitled Applying Fuzzy Phishing to Phishing Page Identification. So if that's not all the words I'll keep clear, I'll just try to make them clear as we go along and onwards. Some stuff about me: I spend most of my time working with malware, with honeypots and stuff like that, but as you might assume, I also tend to play with phishing sometimes. Identification, of course. And you can follow me on Twitter if you like what I'm going to talk about here. So, I assume everyone in this room here knows what phishing is. We also tend to assume our users know what phishing is. Everyone has to go through regular corporate trainings, awareness campaigns, and stuff like that. Well, I'd just like to talk to you a bit about the definition of phishing to underline a couple of important points. So what someone who does phishing tries, using a web page in this case, is to gain the user's trust so that they will reveal some sort of information that's important to them. The best way to do that is to use graphical markings and stuff like that. Send the phishing page out to as many people as possible, and then hopefully they will send something useful. So if you're wondering why I work with this, the reason is we try to maintain an IP and domain reputation database, and you've probably seen phishing URLs before, and might be wondering why bother, since you can generally tell from the phishing URL. Of course, we know users don't generally tell from the phishing URLs. You might also wonder, after I'm done presenting, why I wouldn't go with something like using word-based identification, some sort of word cloud. And if you look at the URLs behind me, you can probably see, well, there's Google Doc in there, there's Gmail inside. You can probably tell it's a phishing page. But the truth is, a lot of people don't. And we also have this rule where we definitely want to find out that something hosts a phishing page. So not just rely on the assumption that if there's a URL that looks like phishing, there's definitely phishing over there. So to improve the detection of our phishing, I decided to look into the current state of the art in research, and saw a lot of people talking about visual hashing. Visual hashing means taking an image and then trying to generate a stream of bytes, preferably something that you can compare to another stream of bytes from a different image, and then say these things have about the same content, there are some similarities. Okay? My idea was, well, you know, phishing relies on that whole graphical marker thing to gain trust. Most likely this should work. That was my expectation. I tested it with login pages such as these, and lo and behold, it actually did work. And then I began to run into the limitations of this approach. First one I saw was rendering failure. So when you access a website, sometimes you get stuff that doesn't load for whatever reason. We've all been there, right? With phishing, that's even more pervasive, since phishing pages and their resources sometimes get taken offline, so they might not be able to load an image from somewhere. Then you have the usual network hiccups from the ISPs. And then from time to time, a headless browser you're using simply doesn't render in the allotted time. And you might say, yes, but a legitimate user wouldn't probably be fooled by these. So I shouldn't have to worry about these. But sometimes you have incomplete failures. What happens if only 5 of those images get loaded instead of all 6 of them? Someone might actually say, okay, looks safe. I'll just insert my credentials in here. So this was one of the reasons I decided with no-go on this. The other one is that thanks to the magic of HTML and CSS, you can actually do very small modifications to a phishing page and obtain a completely different visual result. Like in this case, simply changing the URL of a CSS URL parameter, you can just go with a completely different background. Again, first idea is yes, but I, for one human, can definitely tell that's about the same thing. It's a login page. But a simple visual hashing algorithm can't know that. If I go with something more advanced, it might be able to say, yeah, there's some sort of background and a big green blob in the middle, and this one also has a green blob in the middle, so pretty similar. But the more and more you go into visual hashing and image processing, things get more and more resource intensive. And since we're talking about something that has to work at scale, the basic idea is it has to work correctly as best as possible, and it also has to be dirt cheap when it comes in terms of computation. So I decided to give up on this approach and then went back to the assumptions of the phishing process. So an author tries to create a login page template, then deploys it at scale, and then at the end will finally profit from this. The idea is deploying at scale generally implies automation. I'm not just going to SCP on 1 million websites and copy stuff from place to place. And automation generally means I will have to give up at some point on adding too much randomness to make sure things continue working. What kind of randomness can I have in an HTML page? Well, in phishing pages, I've seen a couple of examples. The first one on top is a form action. So when you have a login form, it has to have an action property that says, where am I sending the data to be processed for this form? And if you're going to deploy stuff on different servers, the form action will change from place to place. Sometimes authors also use specialized cloning tools, and these, especially in their free forms, tend to add comments. Like you see the second one, the blue one, that says mirrored from somewhere, also has a timestamp inside, so when I'm dealing with the HTML source, this will change from page to page. There are also some websites that, when cloned, have copyright information at the bottom. One author might be using a template that he generated in 2014, the other one from 2015, but most of the page stays the same. And like I said, the other trick with simply changing one of the URLs, referencing one of the necessary resources. So the idea is to find a hashing algorithm that will ignore these small differences. If you work in security, you're aware of hashing, and mostly cryptographic hashing, which has this security requirement that when I make modifications, that will imply a lot of randomness in the final hash, because I don't want to be able to tell what was changed in the stuff that was hashed, right? That would be grave danger to security. Fuzzy hashes, on the other hand, they don't work exactly the same. They have some statistical probabilities of doing stuff, and what I found was that some have a property, let's call it locality, that works something like this. When I make a modification in the input in one place in the file, it will be output in a similar location in the hash, so that if in the input file I make a modification in the beginning, the modification will be at the beginning of the hash. Same goes for the end of the two. You can see these two examples. So they're both fake Microsoft credential login pages. And using this approach, they have very similar source code. One of them simply has some form action stuff URL to be submitted, different in the beginning, and they have some copyright information in the end and a timestamp. So using those two, the hash gets modified, but it gets modified only just a bit. So now I have a method of saying how different these things two are. When I can say how different they are, I can say they're about the same, they have a distance in between, and distance means I can actually go ahead and do clustering of the stuff. So these are clusters obtained using some phishing pages that I found as templates. So the base idea goes as this: find as many phishing pages as possible, generate signatures for them, try to cluster them together, and create signature packs of sorts that you will there compare new phishing pages towards. And then you can use this to classify. If you're wondering about efficiency, this approach works pretty well. I haven't had it have any false positive while I was testing. The way we use it is also to correlate with other detection methods, both commercial and privately developed. And we've had an increase in the number of detections thanks to having this good extra vote. Overall, it's been worth my time investigating this, and it's been a lot of fun just to poke around seeing phishing pages at work. That's it for me. This was a lightning talk, so I have to keep it short. If you guys have any questions.
Okay, thank you so much, Adrian. We do have time for questions, so let's check if we have.
Just a quick one right here. Have you thought about using machine learning to detect such pages?
Yes, we do have a phishing engine trained using machine learning, and it does have some good results. Of course, it does have some bad results from place to place. We've used it, and it's been successful.
Is it a supervised model, or is it an unsupervised
Yes,
model?
it's a supervised model that we've trained before. We use the data we detect from time to time that we know has been validated, and then do retraining using that to be able to detect more and more stuff.
Cool, cool. Because this looks to me like an unsupervised machine learning approach. Like a
Well, it's not
clustering.
machine learning.
Of course,
It's
of course, yeah.
practically signature-based. It might work, but I haven't actually tried applying this.
Cool. Thanks.
We have another one here. Adrian, I'm here.
Oh, there you go.
Yeah, as I saw this, you kind of compared HTML source code.
Yeah, that's it.
So what if somebody like minifies it, but with a random class generation pattern? So it would be kind of different.
I've
And
seen.
still maybe look exactly the same.
Yeah, I thought about that idea. Actually, you know, fuzzy hashes have been used for malware detection up until one point where packing became so often that the approach simply did not work. Right now, there's not that much that I can see for phishing. There is a trick that I've seen where they basically generate an empty page, add some JavaScript code, and the JavaScript code calls some AS encrypted blob. Actually, there were two instances. One said AS, do AS decrypt, something like that, and the truth was they were XORing with 1 byte. But I guess it was just to scare people away from analyzing. And the other one actually used an open JavaScript implementation of AAS where they used decryption on the fly. The thing is, most of that stuff, most of the encrypted blob was grabbed from somewhere else, and that minimal content that I had from the original phishing page was actually enough to classify stuff like that, because what I have right there is just like you have for malware, those generic crypter, packer, or whatnot detections. Basically, I'm detecting this approach of being used. And there aren't too many websites which would have a legitimate reason of doing some of this. They could add much more randomness if they want to, I guess, but so far it works. So it definitely won't work indefinitely. So.
Okay, thank you so much, Adrian.
Thank you.